So now I'd like to introduce William Hadala, who is the CEO of iWire 365 and our sponsor today. And he's going to talk about this Smart Gigabit Campus Challenge that he's proposing, and he'll give you all the information about it. So, William?
So thank you for your attendance today. We're really excited about this project. iWire, we've been around for about 7 years. We've been designing, building, and maintaining wireless and now fiber optic networks, as well as building small micro data centers. Though we're based in Richardson, or working within the City of Richardson, we're really focused on more of the rural and underserved cities across the United States. Sometimes we take for granted the broadband that we have here in our big cities, but in Richardson, where our office is located, was really what we called a digital donut. It was the old telecom corridor. There was a lot of fiber going through the neighborhoods by companies like FiberLight, but the problem was that there was a lack of connectivity in that area, and the city recognized that. So for us, it was a perfect location to be in, because what we're trying to do is build out these gigabit cities. But when I used to work for Clearwire, I was basically laughed at when we said we could build wireless broadband with low latency and high bandwidth in rural cities, because you can't justify the investment in it. So I set off to prove everyone wrong on a 7-year proof of concept, growing the company at 182% year after year, to actually show that it can be done. The two primary anchor tenants that you need to build a fiber optic or a gigabit network in any rural city is really your utility in your municipality. The carriers look at data subscribers as how many cell phones, how many circuits can you sell. In the smart grid space for utility automation, we look at subscribers as all the devices that are out there in the field, whether they be substations, meters, IEDs, and so forth. And so when you looked at the BTOP stimulus money that came out in the early 2000s, or actually 2008 and on, you saw a lot of utility automation being put into place that required broadband to communicate back and forth. So we saw a lot of microwave being put out in rural cities, fiber, and so forth. So that was anchor tenant number one. The second is municipalities. As we're building utility networks for rural electric co-ops, we found that we were also working with public safety. And with public safety, as you know, we have to build this FirstNet public safety broadband network across the United States, which is data, voice, and mobility. In order to do that, it's going to be a huge initiative that supposedly the government's going to run, and the carriers are not going to be part of as the primary operator. But in order to build out FirstNet, you're going to need a lot of wireless broadband infrastructure. At the same time, you have more and more police officers putting on cameras on their officers and in their cars. Whether you know this or not, the typical officer per day is actually about 10 gigabytes worth of data that needs to be stored. In bigger cities, that, you know, I chew my gum and swallow it here. I was kind of choking on that for a second. Don't come up and speak with gum in your mouth. But in the camera manufacturers, one of which is in Dallas, which is WatchGuard Video, which we were an integrator to build links between the police cars and the police department. They're selling storage in the cloud. Well, that's a great novel idea if you're in a big city and you got the broadband to put that much data on there. But what about these small, rural, underserved cities? They barely have enough broadband to get connected, to get a decent internet connection, just to connect to email. So we took all these anomalies and started realizing that you have to put broadband in place to not only serve the utility but public safety, but you also have to start thinking about the storage solutions, on-site storage with smaller micro data centers that are almost leaves on a big oak tree, with the cloud being the trunk, the big, the Amazon, the Microsoft, the Digital Realty Trust, the Cyrus One data centers. But distributed in the field is going to need to be these smaller data centers that really serve the content at the edge, connected by either wireless or fiber optic network that hits the parameters of what US Ignite is trying to do. So as we started growing as a company and starting to work with more and more cities, we have the city of Salina in the room. Salina is a population of about 12,000 people. It's going to grow to 300,000 people potentially in the next 10 years, but the city is only 12% built out. They brought our company on board not only to do the fiber optic engineering, but to build out fiber to the premise. They're going to be one of the only cities in Texas that passed a resolution that said we're going to do this fiber to the premise. But then what? Where do we go from here? How do we build data centers? How do we build all this wireless infrastructure? But they're doing it using software-defined networking. It's going to be an open access network. In a lot of rural and underserved cities where AT&T, Verizon may not be building network, they may want to be a service provider if you can build out that network and open access where any carrier can be in there. So it's one of the parameters of that. But on the same note, we're seeing that now 5G is on the brink, and with 5Gs, you're actually looking at smaller cells. In a lot of these small rural cities, in fact, even the big cities, they don't want a bunch of urban clutter on their buildings that are small micro cell sites, and you can see what these cell phone towers look like. So what we recognize is that LED streetlights represent the next wireless towers. For every one 4G pole or tower that may broadcast X number of miles, you're going to need about 4 to 5 5G sites, microcells that are broadcasting at 1/4 of a mile. At the same time, besides microcells, you're going to see more vehicle-to-vehicle communications. The 5.9, which you guys know has been set aside for vehicle-to-vehicle communications, but ironically, it's right next to the 5.8. So with software-defined radioing, how do we use the 5.8 to tie into the 5.9, but at the same time, put the small cell into the street light that also can sell as a nacelle for open access carrier neutral equipment, that instead of the American Towers and Crown Castle owning that infrastructure, how do we put our cities in a position to own that infrastructure, which they can use for public safety and utilities and what have you. So we became ANIXTER's engineering partner last year. So when ANIXTER Worldwide bought HD Supply in the utility space, they bought HD Supply's utility power solutions because they needed access into the utility market, and ANIXTER wanted to bring all these next generation products that they're distributing for some of the largest OEM resellers. And so with that being said, we recognize that these streetlights were the key to bringing this all together. But most importantly, you got to figure out, the first thing to really understand is, what is a gigabit network? You know, in our definition of gigabit network for the city of Salina is 100% coverage, every rooftop, house, and business. Okay, so what is gigabit community? Our definition of gigabit community, which you look at Kansas City, Chattanooga, and God bless Google Fiber. You know, they did a fantastic job showing a model could be done that somebody other than a carrier can offer fiber to the home or to business in using gigabit speeds. But we believe that if they would have went after the commercial market first versus the residential and using the same principles that we have used for utilities and municipalities, they would have been successful. But their blueprint, their architecture serves as the foundation of what we as a company and what we hope you as developers that are creating these solutions can bring into an ecosystem to make 100% coverage to every business and to every home, end-to-end connectivity, where you have at least, you know, when you, just as we were talking about having a concert here, low latency. When you start thinking about video streaming, when you start thinking about the use of video in public safety, or even analytics for IoT on sensors and devices, you're going to need low latency, but most importantly, how do you use the extra? So if you bring on your utilities and your municipalities, you have all this extra bandwidth for all your end users. It's a no-brainer. But the problem becomes, how do you prove out this technology in a way that becomes a living lab? The other side to becoming a gigabit city, whether it be Richardson or the city of Salina, or whether it be a city in Hooker, Oklahoma, or in the middle of New Mexico, is that from an economic development perspective, their greatest challenge is, how do I retain businesses, but how do I attract businesses? You know, it's great that Dallas is growing the way it's growing, and it's wonderful that you see companies like Toyota and HEB moving into town. But, you know, for most cities across America, they're dying. When Route 66 used to go through every main street and the interstate highway system came through, it put a lot of these cities out of town. We see it. They're ghost towns. If these cities cannot have access to technology, specifically broadband, gigabit broadband, these cities will disappear and dry up. So when you look at economic development, how do I attract businesses to my community? But most importantly, how do I retain them? You know, we see young students go off to school that are from these small communities, and they're not coming back. So with that being said, and understanding that, yes, we are in Dallas, but we are focused on rural and underserved, it's how do we create a living lab to demonstrate that this stuff actually works, and how do we commercialize it through a partner like ANIXTER that has global distribution. So beyond the $10,000 that 2 winners will win, we've got a channel that these people aren't providing all this equipment for just, hey, this is great, it's awesome, but they want to start commercializing this because we've got customers that actually need this. For those of you in the room that are non-technical, you know, how fast is a gigabit? If you think about that, if you look at the very, very top, that's actually Netflix. You know, how many of you in areas where there isn't really good connectivity, you know, it's buffering, buffering, buffering just for one stream at standard definition in your house. You know, when you look at 1 gig, you know, it's equivalent to 208 streams of Netflix at once. The ability to actually take a 60-minute video and upload it to YouTube in less than 10 minutes. And so when you think about that, even from backup, I mean, gigabit connectivity is awesome, but on the same note, you need practical applications. So for this challenge, what we felt, and just some background on this, is down Glenville Drive, we wanted to put these LED street lights down Glenville because a lot of our customers across the country wanted to see this stuff. This is all vaporware, William. No, it's actually products that work. But where is it deployed? It's not that it doesn't exist. You need actually a community that can demonstrate its use and shows that it actually works. So we talked to Encore, and Encore was like, well, you know, in order to put LEDs out in our service territory, we got to go to the PUC, the Public Utility Commission, and because our parent company is having financial issues, in order to get an LED tariff to switch out our street lights to LEDs, we're going to have to do a whole new rate case. It's not going to happen. Well, what about the City of Richardson? So Richardson and Encore came to our offices. Well, we as the City of Richardson think this is a really great idea, but we're not quite sure if this is going to work. So all of a sudden, UTD showed up, and we were excited that there was an opportunity to demonstrate it. So for this challenge, and knowing that the university it represents a small city, just like Mike said. And so though we're on a university campus, when you developers think about this, we are trying to imitate a small city. There's energy here. There's education here, there's transportation here, and most importantly, there's public safety. Our mission when we build out these networks beyond giving gigabit connectivity to every person, every business, and every city is this is really a public safety mission. You know, we need to have better safety in our community. When we start looking at fire and disaster, and you know, when you look at FirstNet was created because of 9/11. Multiple responders couldn't communicate with each other because they were on different radio systems. On the same note, you have all these other aspects here, and this presentation will be at your disposal. So when you're writing these applications for what you think can be developed, we really need to focus on the public safety aspect of it. And as I wrote here, and we hit 4 of the 6 areas of potential opportunity: public safety, energy, education and workforce, and transportation. In these smart LED streetlights, and there's something here about LED streetlights. Verizon just bought an LED streetlight, and we're a Verizon partner. We work within their IoT group, which is a fairly new relationship, but they just bought a streetlight company. They see it as a small cell opportunity. But within that, what if you could embed other things into that streetlight, such as surveillance, with the ability to use right here? Imagine you can have a fiber in, and again, this is all up. We're having these conversations with the university as far as the sandbox is concerned. Do we tap into the fiber network, as Gia said, of the university? Or do we also take this fiber switch and plug it into a water tower using milliwave technology, maybe in the upper 60 gigahertz range? All this type of equipment will be provided for this test with low latency. So now we have an aerial fiber connection. But within the street lights, we're using multi-point to multi-point technology to communicate with each other. When you look at the LA transportation system and the San Francisco transportation system, what they're doing is they're actually taking a fiber connection here, putting a base station here on the point to multi-point, and then down line they're putting subscriber units. But they also have 4 cameras at every intersection broadcasting back and forth. So the question becomes, what is the backhaul network we're going to use here? And we're looking for ideas. We're going to provide microwave, we're going to provide Wi-Fi, 802.11 AC. We're working with the patent holder for ultra broadband. I got a phone call on the way today. They are giving us the exclusive franchise to launch this in North America to every electric co-op. That is going to be the underlying technology here. That's exciting. That's 1,500 megahertz of bandwidth at 1.5 gigs per second using frequency reuse. What can we do with that, guys? We think about Salina wanting fiber to the premise to every home. But if you go up to Salina, you got Mustang Ranch, you got some of these other developments that are already built out. Are you telling me you're going to take this beautiful brand new street and micro-trench it and fiber to everyone's home while we're building out the rest of the fiber because the city's about to pass an ordinance requiring every developer to put fiber to the home? No. Put ultra broadband out there so now you can deliver fixed wireless to the home. But how do we take ultra broadband and how do we integrate them into the streetlight? And at the same time, how do we take multiple radios? We have a streetlight that actually manufactured by a partner of ANIXTER that actually has 2 radios in it. One is a 900 megahertz. Well, what's 900 megahertz used? That's used for IoT. It's used for things like AMI. It's used for water and gas. At the same note, there's another radio in there for Wi-Fi. Well, what can we use for that? How do we put the ultra broadband into the streetlight, but then how do we take an eNode B for LTE or 5G and incorporate that all into one? So we're going to be providing all the tools, cameras, streetlights, wireless, and so forth. But most importantly, how do we build applications that people like public safety can use? The IoT with Tech Titans, I showed up at a few events, and I am a small company, and I feel blessed to be up here and had the growth that we had. And as I listen to companies like Hitachi and others talk about IoT, the greatest challenge that these companies have with implementing things like Hitachi Visualization Suite, which is taking video feeds from many cameras throughout a city. How do we sell these things to public safety? They don't have the budgets for this type of technology. The beautiful thing is if we start converting all the street lights to LEDs in small communities, they're going to see a 70% reduction in energy cost. Do you know what that equates to? Millions of dollars per year that can now be used for public safety applications. One such public safety application that we'll have at our disposal here is the IBM i2 Analytics Suite. IBM, I'm sure you guys have watched these shows called The Hunted or Person of Interest. i2 Analytics is the ability to take video feeds and public records and private records and credit scores and all this information. So if you actually have a public safety event happen, you could actually use a decision tree to figure out who all these people are involved, known associates, and actually can drive down and get that person. So IBM is going to be participating with their i2 Analytics platform. We'd be more than happy to provide more information about that. And at the same time, how do we then take all of the analytics coming from these cameras with ANIXTER providing video management systems and potential license plate recognition and facial recognition and bringing that all together? So as you can see, the vision is really to provide this high bandwidth, low latency network that can be used for public safety. One of the applications, if someone in here can figure out how to write it, is how do you detect open parking spaces and closed parking spaces, especially here on campuses, especially in big venues where you're driving around and the only way you can really have a good system put in place for intelligent transportation is tearing up the parking garages, putting little red lights and green lights. That's crazy when we could actually be using the same video to actually keep everything safe to see, is this parking space closed or not? And how do you create an app that a student actually gets an alert saying, I'm late for class, I've got to be in this building, or I got to go to this venue, and this space is open and this space is closed. The other aspect of this is intelligent transportation. You get these venues at these universities or anywhere in town, where is the traffic flow? Where is it congested? Where is it free? How do I redirect traffic and what have you. At the same time, some of the tools that are going to be provided to this thing are things like sensors. I know that ANIXTER really wants to take FLIR cameras. So how do you use FLIR cameras to actually detect voltage on poles, transmission poles, substations, and what have you? And again, there's a lot of different things that are going to be tied into this thing, which is it's more than I can sit up here and just talk about and go through all the possibilities of what we're trying to create. So on a deployment on a small street, this is down Glenville Drive, we had 4 street lights that were here, and so this will be in your kit as well, of how the configuration of the street light poles work, which is point to multi-point technology, and with a base station up on a water tower communicating to each, with only one fiber head in, which was right over here, above here, of the Wi-Fi fiber, and then going across this network. The street light, again, with the cameras, one of the problems that we saw with the cameras that we have available to us is they're putting these cameras in the street light, but for like license plate recognition, you need to be more at a 90-degree angle than a up in the top, which is more of a fisheye on that thing. So these are things we're trying to work through right now. And again, if some of you in this room can figure out these solutions, there's markets right now waiting for these things. But the cool thing is you've got the network side that needs to be figured out. You've got the hardware side, and then you have the software side of all the potential applications. One of the other things that we're going to have the ability to have in this test or sandbox is actual, I'm sorry, I'm flying through here, is the ability to actually have to get gunshot detection in here, and so forth. And then as I look at my notes, I say gunshot, air quality, vehicle to vehicle, and obviously that ultra broadband. Now, the other side of this too is the security fabric. You know, how are we protecting these devices? Knowing that the public safety video aspect will have to be CJIS compliance, which is part of the Department of Justice. So access only to public safety, that needs to be designed into this thing. Into the security, are we dealing with PKI certification on feeds that are coming into? What about edge point protection? We're a partner of Palo Alto Networks, which is all about putting traps and firewalls and not necessarily using antivirus, which is old and outdated. But how do you integrate this into this complete ecosystem? So that's where we're at. A lot of applications to be created. Beautiful thing is with the city of Salina here is that what we create here and whoever wins, this is technology we need to be deploying, but they don't want to deploy technology unless they know it's really going to work. So as you can see, there's a lot of applications that's going to help and improve the quality of life of people around the country and the world, starting here in Richardson. So we're really excited to work with you guys. Because we are an ANIXTER partner and ANIXTER is a supplier, if there's things you need that we aren't putting up here, let us know. I mean, it's just a phone call away to get the tools that you need. So thank you very much.